Welcome, my name is Robert Magee. I work at SideFX Software, and I'm here today to talk to you about Houdini Foundations. We put a lot of tutorials out on our website at various different levels, and the Houdini Foundation series is designed to be an introductory set of tutorials to get people started when they're first learning Houdini. So this particular presentation is based on a new tutorial we just posted up last week. And the general concept is Houdini as a pipeline in a box, where we're going to look at the nodes, networks, and assets that you use in Houdini and talk about how they go beyond just creating end product, but actually about how they create workflows and how those workflows can help you in a pipeline, whether you're a small individual artist doing your own work or whether you're a larger studio trying to pipe lots of work through the system. So the three products we're going to talk about primarily in here are Houdini, obviously, Houdini Engine, which is a very important technology we have that sort of works under the hood, and PDG, the Procedural Dependency Graph. And we'll talk about how that can fit into this as well. And pretty much we're going to build everything from scratch. That way you'll be able to see how we go from our first node all the way to the system that we pipe through PDG. So just define some concepts and ideas within Houdini. Like we said, it's a node-based system, which means that everything you create in Houdini creates a node. These nodes get connected to build networks, and each network defines a recipe, something that can be done over and over again. And that ability to use it over and over again, maybe with a little tweak here and a little tweak there, is what begins to create this concept and idea of a flow of data. And networks can be packaged up into digital assets. And what that means is that you take the network we have and you collapse it into a single node. That single node can then have a high-level interface built for it simply by dragging and dropping parameters from the nodes inside. And that high-level interface can help you as you then take it back into Houdini as a tool. And that interface will be used for that tool. Now what's interesting here is all the complexity of the original node network still exists within the asset, but it's buried and locked down underneath. What's also neat is these digital assets can be built mainly through normal artist workflows. So you don't really have to be a programmer to make these kinds of tools. There's lots of programming opportunities if that's what you like, but it's not a necessity to build a digital asset. And the digital asset essentially becomes a tool. And it ends up being an equal partner within the Houdini environment to other nodes. And as a matter of fact, a lot of the Houdini tools that ship with the product and are up on the shelf, they're actually digital assets that we built to help you as you work. So this ability to make digital assets can work at many different levels. So pipeline in a box. This is the essence of the fact that everything in Houdini is about building these networks, building these recipes, and ultimately potentially packaging them up. So nodes that get put into networks and wrapped up into assets and then shared. And this can be a really powerful thing. And even if you're an individual artist, there's probably lots of repetitive work that you have to do to get a project through, from idea to reality. And having the ability to package up some of those workflows and speed things up can make a really big difference. So the first thing we're going to talk about is let's just talk about nodes. And we're going to create this sort of toy block. And in that, you'll be able to see how Houdini lays down the nodes and begins to create the networks that flow the data. So in the interface in Houdini, you've got the viewport. We're going to just put a cube down there. At first, we're putting something down at what's called the object level. And we can resize it using some of these parameters up here. To get the cube that we want. Then we can sort of zoom in, get a little closer to that. Now what we want to do is we want to select the top face of this so that we can do some poly extrude. And you'll notice this dropped us down into what's called the geometry level, where we manipulate geometry. And notice that the box had a node, and now the poly extrude had a node. And then the parameters sit on those different nodes. If I want to change the shape of this, I can put an edit node down, and I can take that and turn that into a circle. So I just right click on here and say make into a circle. And again, that edit is a node of itself. If I poly extrude again, I get another node. And this is the sort of flow of all the pieces that go into this. And I can at any point set the accurate parameter and work with that. Now what I'd like to do now is bevel some of the edges, but not all of the edges. So in order to get the ones that I want, I'm going to use a group. Oh, wait, sorry, before I get there, I got to put the hole at the bottom. So again, a couple more poly extrudes, just press Q to get that, do a bit of an inset. And then Q again to extrude that again. And then that will allow me to push that up into there. And then put a value in there. Okay, so now that I have all this, I want to do some beveling of some of the edges. So rather than just select all the edges I want by hand, I'm going to use sort of a Houdini tool, the group node, to find the ones that I want. So when I first do it, I say I'm going to call this bevel underscore edges. By default, it uses the selection that I had, which was all edges, which I don't want that. So I'm going to turn that off. And then I'm going to go down here and I'm going to actually say, give me a minimum and maximum angle. And I'll make that basically 89 to 91. And because of that, you'll see that it's actually selecting all the sort of right angles, but not the shallower angles. So that gives me exactly the edges that I want to poly bevel. And being able to do it with a group like this is sort of useful because even if the shape that I fed into it changed over time, it would always find the edges that I wanted no matter what. And that's something that makes something just a little bit more procedural. Type in a value for that. And we'll add in a little bit of detail, just make it round. And there we go. And this gives us our first block. And we can just look at that back at the object level. Let's just give that a name, single brick, and we can look at it with subdivision surface. Let's do that, and then select it, and we'll just shift plus will allow us to look at it as a subdivision. And there we go. So we got one brick, and this was built using a series of nodes wired together to give us a flow of data. So the next thing that we're going to look at is networks. So what we're going to do is we're going to take Flip, this little guy here, and we're going to create a series of nodes that convert him into a brick version of the model. And you'll notice here that not only do we have the bricks in the shape of the creature, but also that the coloring of the texture map is going to get pulled over and applied to this as well. And so we can do this very simply using the nodes that we want to extend with here. So we'll hide the brick, bring in this shape. This is one of the test geometry shapes that we have with Houdini. And we'll just go in and just quickly clean this up a little bit. Let's make it a little bigger so that it suits the size of the bricks we have, and raise it up from the ground. And then we can look at that from the 4 different views. Just got to make sure that it's sitting on the ground nicely. And there we go. We're ready to go. Now, to make this into points, that's a fairly simple thing in Houdini. We have a tool to do that down at the geometry level, and it's called points from volume. So we just place that down, and the geometry feeds in, and it creates a whole series of points, which we can just highlight those in yellow. Then you'll be able to see them a little bit better. There we go. So you'll see that the points exist within the shape of the creature and not outside. So that will help us in the building of the bricks. So now that we've got that, let's go in and just change the name of that. And now we can take the points and the brick. And by selecting the two of them, we can combine them into a single network. And that will allow us to work with them a little bit more effectively. So using a tool up here called Combine, we combine those into the same network. And currently they're going into a merge node, so we're getting a bunch of points and a brick merged together. We don't want that. So we're going to delete that merge node, and we're going to replace it with a copy to points node. And this copy to points node, we can turn on pack instances. So this would be a more efficient way of copying geometry to the points. And there we go. Now it's looking a little bit wrong, and part of the reason here is that our volume to points was at 0.1 separation, but our bricks were 0.2, 0.2, 0.2. So if we change that to 0.2, that's looking much better. Now we're not seeing everything right now. We're only seeing the packed images right close, and that's because there's some display limitations. It's getting culled based on a polygon limit, so we can increase that to 50 million polygons. So, and that's it'll display fine because we're using instancing. It's fast and it's snappy and it's doing the job that we need. So now let's take the nodes that made up the brick, and we're going to put them into just a box here, a network box, and that will allow us to take them and just collapse them because, you know, they're not really going to change that much at any point in the process, and we can simplify our network to make it easier to work with. You can organize any part of your network using these kinds of boxes, collapse them, just put it off to the side, you're ready to go. And now we can zoom in and we see that in essence we've got a brick on one side, we've got the flip on the other, the points, and then have the copy to points. So the next thing we want to do is let's just add some color into here. Now you notice that we're adding the colors to the points. We're not adding it at the end of the bricks. We're putting them on the bricks, and then the bricks are picking up they're picking up that color when they get instanced. So that works great in the viewport, but if we actually did a bit of a test render on that, we're going to find that it's not working from a rendering point of view quite yet. We have to do a couple other steps to get it to render properly. So the color attribute that we just placed in the network is not making it to the render. So the way that we do that is first we're going to create a material network, and we're going to put an actual material in there, because right now we're just using whatever the default material is in Houdini. And we want to bring in a principled shader. We're going to put that in that network, and we're going to call that brick material. And we're going to use that, drag that on, put that onto the geometry using a material node here. So we'll do this down at the geometry level. So we've got a material node, set the display on that, and basically tell that to go look at the material that we had. And there we go. Now, that made it darker gray, but it didn't bring our color over yet. There's a couple things that we need to do to make that to work. First is I don't want the darker gray. I'd like to have it a little bit lighter. So go back to here, go to the surface area, and we'll change that to let's say 0.5, 0.5, 0.5, and that lightens it up a little bit. Then there's a little checkbox here, use packed color. And once we check box that, the color attribute is now going to be passed on to the material and will be rendered properly. So that shows you how we can take advantage of that. So if you look back at the original illustration that I showed you, we had done this slightly differently. But before we get to that, what we want to do is we want to say, is the system we built robust enough to handle other kinds of shapes? So we're going to put a switch node in, and now we're going to bring over a platonic object, and we're going to feed that in the other side. We're going to just change the shape on that. You can sort of see it in wireframe here. We're going to change it to a Utah teapot and just raise that up a little bit from the ground. So the question is, if we feed that into the same system, will everything we've created so far follow through? Will the flow of data, will the recipe apply? So we go in and we change the input to 1, and there we go. We've got ourselves a teapot doing all the same things that we had with the rubber toy. So that's how sometimes when you're building up an asset like this, it's good to have this kind of little test to make sure that it can do what you need it to do. Now the next thing we want to do is, instead of just using the red color, we want to take the color from a texture map that came with the original model, and we want to use that texture map to drive the color on the creature. So this was originally a digital asset, and we can actually open up that digital asset, and if we go to one of the tabs here, if we go to the one called extra files, we can save that to disk, and we're going to put that in the texture folder right there in our project. We could pull it right from the digital asset, but having it on disk, you'll see later, especially when we do PDG, there's advantages to having it on disk. So then the question is, well, how do we get the texture map colors onto the points so that they can be passed on to the bricks? So the way we're going to do that is we're going to use VOPs, which is we have an expression language called VEX, and VOPs is an interactive way of building up this. And all we're going to do is we're going to put in a texture node. Now this is the same language we would use to write a shader in Houdini, but we can use it to deal with attributes and other things within the world of geometry. So we're actually going to bring in a texture map, and that's going to literally take the colors from the texture and apply them to the points on the surface. Now we want to promote one of the parameters up, so we're going to take the texture map, which has the default of mandrel, which is one of a default texture we come with, and we're going to promote that as a texture map, and that'll go up to this level here. You can see it right there, and we'll leave that texture map in for now. It'll work for testing purposes, and later we can replace it with the one we saved to disk. Now the first thing we have to do is this attribute is a vertex attribute, and we want to promote it to a point attribute. So the first node we do says take that and vertex attribute, make it into a point attribute. This is CD, which is color. Then what we want to do is we want to transfer that color based on distance from the model to the points. So we're going to wire the points from volume, and we're going to wire that in. And it's a little hard to see there, but you can see that the points now have color. And that color is coming from the texture map that is being promoted over. So the next thing is, just to give us a little more control, we're going to put another switch node down. That way we can choose between a plain flat color or a texture map, and this will become important later when we turn this into a tool. But it's just helpful from a workflow point of view here. So we got a thing called texture switch, and if we switch from 0 to 1, you'll see now we have the texture map from the mandrel pick being applied to the points on the surface. Now if we go back, we can click onto here and we can go into our texture folder and get the texture, and there we go. Now we've taken the texture map specifically designed for flip, and we're applying that for rubber toy onto the bricks. Okay, so now that we have that, the next thing we want to do is build an asset to create a tool out of this, which means taking the network we've got, collapsing it into a single node called a digital asset, which will function as a tool, a reusable tool that we can use in a bunch of different ways. So let's get right to it. So back in this network, we're going to select everything except for the teapot, because the teapot we're going to use as an input for a custom asset. We're going to go in and turn this into an asset. Now a digital asset goes into a file on disk called a .hda file, which represents Houdini digital asset, and that gets stored on disk. That holds the definition of the asset. And we're going to put that within our project directory. We have a HDA folder there. We'll put it in there. And we're going to call it Brickify. So this is going to be the Brickify tool. And we accept that. As soon as we do that, it's going to bring up a window, which is where we can start to set up the interface or the UI for this particular tool. So the first thing we do is we want to say, well, we don't have to have an input, but if we do, we'll accept one of them. And then what we can then do is dive back into the network, which was collapsed. Let's just rename it before we do, just so we recognize it easily, Brickify asset. And if we dive right into there, then here we go. We can now go in and start to promote parameters, things that are in the network that we think we might want to use up at the top level. So the first thing we bring over is one of the switch nodes. And this is the switch node that allows us to switch between the different shapes. So currently it's called select input, and it's got numbers, so it's a little boring. It's not going to communicate very well with anyone, but it does work. We can go between the teapot and the shape. But if we want to make it a little friendlier for people who are going to use our tool, we might want to go in and let's change the name to shape, so that'll be easier to figure out. And then instead of a slider, we've only got two options, so we're going to make a menu out of it. And the menu options are going to be 0 for rubber toy. So a rubber toy will always be the default shape. And then we can also go, and 1 would be the custom shape. So that's the input that's coming in from the teapot. But because the teapot sits outside the tool, we'll be able to plug other things into that tool later on to get custom results. And there you go. You can sort of see that, the ability to pick those two there. Now we can also bring over the texture one, so that would allow us to switch between either using color or using a texture map. And again, it uses pretty much the same technique to set up a menu between color and texture. So anything you need to build into the tool, you can do it this way. And as you can see, I'm not writing code to do this. It's all a very friendly interface. An artist can essentially start to build their own tools as they switch back and forth between these different options. Now, once you have that, you can then start to do other things like say, well, let's bring that color up because, we might want to change the color. Or we might want to take that texture map and we might want to assign a different texture map. So let's promote that up. And once you've got all that, you can make sure, I would just make sure that the default is the mandrel texture. That way it always finds something. That'll change it on us for the moment, but that's fine. So the mandrel is always available, so it's easy to put that as a default. And there we go. So all of these bits and pieces are starting to come into play, and we're starting to create a high-level tool based on the network and the flow of data that we had creating this. So now we've got this working as a tool pumped into the rubber toy. But what we'd like to do is let's create a different test geometry. Let's put down the crag. That is a sea monster that we have. And let's see whether that same tool can function with this object as well. Again, making sure the asset's always good along the way to test out what you've done, make sure that it works in a larger context. So there we go, we've got the shape of it, and just down at this level we can go in and type in Brickify. There's the tool, and by default it's a rubber toy because that's our default shape. We have to change it to the shape to custom in order for it to respect that and create this new one. So that works out great. And just like we did before, we can bring up the texture map for that particular shape and save that to disk. And that way we can make sure that the crag is using its proper texture. So we go and we pick this and we go get the texture map, and there we go. So now we've created something where we can have a texture map and a model and convert it into a sort of a brick version of itself, which is great. Now, just because it's an asset doesn't mean that I'm finished, because these assets can be updated. And by updating one asset, you change the definition on disk, which means all the assets benefit from the change that you make. So what we can do in here is say, well, what if we want to animate this? What if we'd like to see the bricks build up from scratch? Well, how could we do that? So the way that we're going to do that is by essentially deleting some of the points based on time. So just like we did with the group before, we're going to put another group node down, which is going to grab the points, and we're going to put an expression in here that will help us hide some of the points. So we're going to do it based on start and length. And the length, we're going to put an expression in, which is $F, which is the frame, -1 times 20. So this will take the points and get rid of them. We're going to invert the range, and so the points will sort of disappear as time goes by. Now, at this point, we're just adding them to the group. They're not actually disappearing yet. To do that, we would actually have to add another node called a blast node, and the blast node will take in the input of the first, and that will allow us to see this in action. So if we just look at the points, we can see the points grow over time, and they're growing in sort of a random order. They're growing based on the point numbers on the points. So if we want a little more control over that, like, control is always good, what we can do is we can put another node in here called sort. And sort will allow us to say, start from the ground, have a vector going up, and that will number things in that order. So now you see the lower bricks get built first, and then they build up from there. So we're controlling a fair bit inside this network to create this animated brick effect. So that's great. Another function or functionality within our tool, the ability to animate that. And just like everything else, we want to make that an option. We don't want to force you to animate it, but we want to make that an option. So we'll put another switch node down, and the switch node will allow us to take either the animated ones, we'll call this the animation switch, and we'll be able to feed in the unanimated version onto one side and the animated version in another, and then we'll go out from there. And then, just like we did before, we'll be able to promote that attribute. And so right by default, it's not animating. If we switch this to 1, then it does. So always the ability to add control. And again, I'm doing all this without writing code. I'm doing this as an artist, working with these nodes and playing with these attributes. So again, I have to say, well, I need to promote this up. So I'm going to go in and I'm going to promote that switch node up. But before I do that, let's just add a separator in here so we can separate out some of the features from some of the other ones. And we're going to promote this up, and this time we're going to call it animate, and instead of having a menu, we'll just have a checkbox because it's either on or it's off. We've only got the two options. So it either animates or it doesn't. So we're going to choose toggle, and we're going to set the default to 0 or so. Now we're also going to bring in another parameter. So we multiplied the speed by 20, which is just a random number we picked out of our head, but we may want to have more control over that. So we're going to create an attribute called build speed, and we're going to use the build speed in place of the number 20. So that way, if we have a particularly large object and we need the bricks to draw a little faster, we can control the speed of that using this. And we can actually set the range when we're setting up the tool to lock it down in one direction. We never want it to go lower than 1, and we don't want it to go, ideally beyond a certain point. So we accept that, and these are now functionalities on the tool. And we're just going to change this expression to, instead of using the 20, we're going to use a channel reference to go get that build speed that we had. So this is an expression, not quite programming, but it's starting to dive into that territory. But it's still pretty artist friendly. So once we have that, we save the asset. So all that changes we made get stored into the definition on disk. And then we lock it up. So when you lock an asset, you can't touch the nodes inside. And this is what happens when you give a tool like this to somebody else. They shouldn't be touching what's inside. They should just be playing with it, what's above. Now notice the speed was very slow because it was a 1. Let's bring it back up to 20, and it goes back to where we had it before. And that's perfect. So the tool's definitely doing the trick there. And what we can do is we can look over at the second one, the squab, go down into its level and say, what happens if we animate that? And it's pretty big, so it's not going to go very fast. So we're going to multiply that by 100 to get a much better speed on that. Okay. So that gives us I think enough functionality in our asset. And before we go on, I just wanted to show you another kind of digital asset somebody created. This is from the community, Mark Chevry, and he created this amazing book asset. So you can see how far you can go with something like a digital asset. His allows you to get the shape and size of the book, what the texture is, whether it's animated, whether the book's open, all of that built into what the asset is. So this is the kind of extent that somebody can go to really push the idea of a procedural asset as a tool builder, as an asset builder within a pipeline. And he's got details for the shaded edges, the serrated edges. So just imagine building up a library of books quickly and easily using this. And as later we're going to see, there's ways of automating this, so you can use his asset to pump out 100 books or 1,000 books, all unique based on randomization of some parameters and things like that. So it's pretty great example, and I was appreciated that he let us put it into our presentation. So we just did the pipeline in a box. We built nodes and networks, flow of data, built an asset that we can share with other people using Houdini. Well, now we want to talk about breaking out of the box a little bit, about being outside of Houdini and using things like other applications or the farm to really extend this procedural framework and how it works. So we're going to talk about two main technologies, Houdini Engine and PDG. So Houdini Engine plugins are something we have available that allow you to take these wonderful digital assets we created and use them in other applications. Applications such as Maya, 3D Studio Max, Maxon, and engines like Unreal and Unity. So we left this diagram a while ago where we had our networks, making an asset, feeding into Houdini. Well, we had customers come along and say, but we want to use those same assets in other applications. Is that possible? Well, of course, by default, no, because you need Houdini to make that possible. So what we did was we created something called Houdini Engine. And Houdini Engine can be plugged into these host applications, and that allows a Houdini digital asset to basically get processed and delivered to the host application. Under the surface, the Houdini libraries cook the nodes and do the work necessary to deliver that. And then if they use the high-level interface, which does become available in the host application, that interface will stir up a new cook and a new updated version will become available. And so that's pretty exciting. And we're gonna look at that by taking a look at the Brickify asset inside two applications. So here we are in Maya, and we're going to bring the Brickify asset in, which by default gives us the rubber toy. So that's because that's the default shape. If you look over off to the side, you'll see that a lot of the functionality that we created is here. For instance, we can animate this by setting a certain speed to this, turn on animation, and now we can scrub in the timeline and see this animated. So the same feature, same thing that we had working in Houdini is now working here. Now when you animate, it also generates a cook, so it's cooking based on that. Now, the other thing we can do is we talked about the ability to have a custom shape. So what we want to do is reveal a second shape here. This is a sort of a statue of a rhinoceros, and we want to brickify that. So the way we would do that is we would shift select the rhino, and we would say, bring that selection up. And there we go. We're going to create that custom shape. So the custom shape is now feeding in there. We can hide the original rhino, and then there we go. We've got the brickified shape. Now the one thing you'll notice isn't coming across is we're not getting the point colors, we're not getting the colored texture on the points, and we're not getting the texture map. And the reason for that is that not everything always goes into the plugins. There are some capabilities that exist within Houdini that do not particularly exist inside the host applications and the way the plugins work. And in some cases that SideFX didn't program that connection or that bridge. In other cases, the host application just can't handle that kind of information. So in this case here, we just have to apply a shader and render it some other way. But it is good to be aware as you're building something up to constantly be testing, because your plugin might not do everything that you expect it to do. You might have to find another way for that to work. Now here we have the same asset being brought into Unreal Engine. So here we have the rubber toy in the space here. And it can be moved around. And again, we're not getting the color or the texture, but we are, and the animation probably wouldn't make sense in here because the engine cannot work at runtime. So whatever we do from an animation point of view wouldn't function at runtime. But we can use it to build up this world. So in this case, we're going to do the custom shape, and we're going to turn that background platform with the staircase and brickify that. So the way we do that is we say we want to make a selection from here, and we can use the outliner up here to find those shapes. So we'll select a bunch of those shapes, and we'll go accept those. And then it's a little psychedelic, so we'll hide the original shape. And now we can go and walk around and see what this is like. Now this is not just a bunch of bumps sitting on top of there. This thing is now filled with bricks. But one of the things that's nice is when we go into Unreal Engine, we take advantage of their instancing. So this is still pretty snappy, even though there's tons of geometry here, but it's all properly instanced. So it looks pretty good, and it works in here just the way we need it to. So you come around, and there's my brickified shape within the Unreal Engine. And there are a lot of game studios using Houdini to create digital assets, to customize shapes and build things and build assets and level designs inside game engines. So very interesting that this same tool we built in Houdini, we've already been able to use it in a couple different contexts. Now just again as an example of how far you can go with this is an example by an artist named Marina Alexandra Bade. I don't know how to pronounce that right, sorry. She's created this wonderful set of digital assets for building buildings in a context to use in Unreal. And she's created assets for a bunch of different things, not just the buildings themselves, but also pieces like the telephone poles. So she can put buildings in and change their type, what does their look like, put some textures on them, play around with the poles. They got all the hang filled out, and here's some of the iterations and possibilities. And this is where digital assets come in, because once you've got a good asset built, it offers iterations and possibilities and procedurally generated things that would be, a lot of work to build by hand over and over and over again. So lots of saved time, and this is where this idea of pipeline comes in. You're speeding up your pipeline, you're making it more efficient, you're automating things, and that's something that Houdini can give you, which is important. So the next thing we're going to talk about is the procedural dependency graph. This is a technology we brought out recently. It's a section of Houdini called TOPS, or task operators, and it works a little bit differently in the fact that it connects out to the farm. So the way it works is you've got these new nodes called TOPS, and when you feed something into them, you can say, how many tasks do I have? So this thing says, okay, I've got a certain number of tasks. And then you've got a certain amount of nodes on your or cores on your computer. So you get a scheduler, this is the local scheduler, and you say, give me 1/4 of the nodes of the cores that are available. So I'm just going to take 3 of them. And so it'll run through the different tasks 3 at a time until it finishes. If you want to, you can go as high as all the cores except for 1, and that would speed things up. Now you've got more of these tasks being done at the same time and spitting out a result. Of course, PDG is not really about working on a local computer. Its strength comes when you go to a larger farm and using something like Deadline or HQ, and now suddenly you can see this thing lighting up because it's just doing tasks left, right, and center all on different computers and so on. So this takes the proceduralism, what Houdini does, and extends it out into a larger context. And then once it finishes, it says job done, gives you a little tick mark, and the top nodes essentially become a little verification that your pipeline is functioning properly and delivering the results that you need in the end. So let's look at an example of that. And again, we're going to use the Brickify asset just like we did before. So we've got the top network right here, and inside is this local scheduler designed to use as many cores as are possible. And now the first thing we're going to do is we're going to bring in some files on disk. So we're going to use a file pattern, and we're going to go to a directory that currently has 4 models in it. So we're going to pick one of them, but we're going to replace the name of the model with a star. So now what we're going to do is whatever's in that folder, we're going to get it all. Now in this case, it's only going to be 4, but if we put 100 models in there, it would go get 100 models. So we generate that. And what you can do is we've got this item viewer that allows us to see. So when we click on a dot, we can see what that dot is producing. So there are the models that dot's producing. Now we put a node down called an HDA processor. So this allows us to go and get the Brickify digital asset and actually feed it with these 4 models. So we go and get the asset, and to make that work, we got to do a couple things. First is we want to use the custom shape, otherwise we're going to get 4 rubber toys. and we want to use the input from the node above as the SOP input for that processor. Now if we generate and cook that, it's going to go think a little bit. And now when we click on this, we're going to see we've brickified those 4 shapes using this thing, going off and doing its job and spitting the results to disk. Now they all use the mandrel texture, and we'd like to use a unique texture for each one. So we can alt-click this node over to here, where we can say, instead of getting me geometry files, I've got 4 equivalent texture maps on disk, and I want to generate those. So if I go into there and say cook that node, you'll see that, well, this case it won't display in the viewport, but if we bring it up, you'll see I've got a texture map for the pig, and I've got one for each one of these that fits the UVs of that particular shape. Now in order for both of these to feed the digital asset, what I need to do is do a partition by node, which allows me to feed everything in, but then organize how the things are feeding through the system. So if I go and I just set a couple options here, these options will make sure that I'm getting the right association between the texture map and the model that relate to each other. So if I cook those and I middle click on here, well, if I left click on these, they're just going to look like the models because the first input is the geometry. But if I middle click, you'll see that the first thing is geometry, but the second thing is the texture map. And that means both of them are part of the picture now. Now if I go and I generate that again, what we're going to find is that the texture maps aren't working yet. And the reason they're not working yet is even though they're feeding into the system, there's nothing on the digital asset that says take advantage of this. So if we click on the digital asset, you'll see there's the mandrel.pick. We need to change that to say give me the input from the PDG coming in. So we're going to use an expression called @PDG input .1. .0 is the geometry, .1 is the texture map. And once we feed that in, then we can dirty and cook this, and we're going to get the texture maps put on here the way that we want to. So if I have a directory of models and a corresponding directory of texture maps, I'll be able to produce as many of these things as I want. But you know what? Just seeing them here isn't going to help. I need to communicate this to other people in the office to say, look, here's what these models I've generated look like. So I can render them in Mantra. Now to do that, I need to set up a little Mantra scene with a camera. It doesn't look brickified yet, but it will when I actually do the rendering. And that I can just make sure that I use what's called the PDG index, so I can number these things properly when it gets saved to disk. So the 1, 2, 3, 4 based on the index of the PDG coming in. The language in PDG is a little different than traditional Houdini. You are getting into ideas of index and input, and it starts to feel a little more programmy. But still, this is all done. More as an artist. I haven't written tons of scripts or any scripts to make this work. It's just all working out of the box. So now I generate the rendering. Now I definitely sped up the rendering, so it's not that fast, but I didn't want you to wait. And there we go. So there's one of the examples. But we've got 4 of them, and we want them together. So we're going to take the 4 and feed it into what's called a wait for all node, and then we're going to feed that into an image mosaic node. And this will allow us to take this and build a mosaic. Image magic, which creates a mosaic out of that. And if we cook that, we can middle click, and that will bring up. There we go. So if we can do 4, we could put more models in that directory, and we could produce a whole bunch more of them. And not with changing anything. Like that's using exactly the same network that I did for the 4. I can do these 8. Just by plumping them through the system and waiting. And if I had more models, this would have been more impressive, but anyway, you could go on and scale up. But the farm and the cloud become part of this, and you can take this procedural idea and take it off to the compute farm and do hundreds of these, thousands of these if you need to for a project. So if only there was a franchise that had little bricks, characters in them, maybe they could take advantage of this. Anyway, so there we go. So that's PDG. Now, this is an example that we have as a tutorial, a foundation tutorial on creating this. And this is an example sort of bringing two things together. So this is actually a digital asset that has PDG in it. And through our Houdini Engine for Unity implementation, we can actually take advantage of that PDG and spit it out to build buildings for this particular scene. So if you look here on the side, it talks about waiting, cooking, cooked, failed. Those are the same codes that you'd get on the little dots in PDG. So we can get the same feedback here within the Unity interface that we would have got from PDG as we build up this city. So here's a city built out of a particular, it basically starts with a map, a black and white map, converts that into geometry, and then builds a city out of it. If we want to go get a different map, we can say, go give me this map instead, and then it just runs through and processes that. And PDG is working, potentially going to the farm and going and building all these buildings and spitting the results back here into Unity. So all of these things can work inside each other and around each other and together, assets inside Unity plugins and so on and so forth. So it's pretty fun situation there. And like I said, there's a tutorial for that if you want to follow along and get an understanding of PDG. So the next thing I'd like to talk about, let's make sure I got a little time here. Future pipelines. Now there was a much bigger presentation this morning on the new Solaris technology that we have connecting with USD. I'm just going to do a little preview of it, but definitely either watch that presentation on YouTube, it should be up now, and there's another version of it tomorrow, on Thursday, if you'd like to come back and see it live. So basically, USD is a big pipeline solution that's coming, and we're all going to be using it soon, no question about it. We've created a new technology a new part of Houdini for Houdini 18 called LOPS, or Lighting Operators, and it is native USD. Everything in it brings in USD, spits out USD, everything brought in gets converted to USD, and it's going to be a really great way for you to take what could otherwise be maybe a little technical concept and turn it into a more friendly artist concept. Look dev layout and lighting is the main purpose, and the code name for it is Solaris. It actually works within Houdini Core and Houdini FX, but we call it Solaris just to help people sort of get grasp around the idea that this is something really new and exciting. We've also bringing out a new render, a replacement for Mantra called Karma. Karma is designed specifically to connect to Hydra and USD and will work with Solaris. It can also theoretically render USD directly using the Hydra interface. This Hydra interface, which is the API for rendering USD, also will have a whole bunch of other renders which will work within the Houdini interface as well. Renderman working already, other renders will come into play as time goes by, and any Hydra compatible render will work in that way. So I'm just going to give you a little sneak peek of the interface of this. So Karma is currently working in the viewport, so as we make changes and updates, it's re-rendering on the fly right here. So this is sort of setting up different shots with different lighting options. So because it's a lighting workflow, you'll have nodes specifically for assigning lights, and you can have different shots, and each one of these shots can spit out USD files with the proper naming conventions and everything, so that you can build up your USD library. And all the bits and pieces that come in can all come from USD as well. Again, you should watch the full presentation to really get the lay of the land, but definitely an exciting next step for Houdini within a pipeline. And of course, these tools are so artist friendly that, again, that pipeline in a box, the artist being able to sit down and have a sophisticated pipeline at their disposal as a big studio does, that's a pretty exciting thing that Houdini offers for people who are working. You get that pipeline mentality right from the first node you put down, and you carry that through all the way to final lighting, look dev, and rendering. So we just looked at a whole bunch of technologies: Houdini, Engine, PDG, little hints at Solaris and integration of USD. Let's talk a little bit about what this means. This approach we take, the pipeline in the box, creates reusable recipes using nodes, networks, and assets. You can bring these procedural workflows into your favorite apps using Engine plugins. You can extend Houdini's pipeline in a box to the compute farm using PDG. And you can utilize the compute farm in new ways to get more work done faster. And with Houdini 18, you'll be able to integrate USD into a comprehensive look, dev, lighting, and layout and lighting pipeline. Houdini can help you build the ideal pipeline in a box, and I hope I've been able to illuminate you a little bit on what those possibilities are and how you can begin to get started. Like I said, to me, this is a foundation. We have a book, a print-on-demand book online, Houdini Foundations, and we're constantly trying to add new tutorials, introduction to concepts and ideas within Houdini, general model, animate, and render. There's the top PDG demo on city building, terrains, and of course Flip, his tutorial just got put up last week. And so that will introduce you to the node networks and assets. And we plan to have more to come. So if you want to get started with Houdini, just come to the website under the Learn menu, Getting Started. Not only are these tutorials there, but tons of other tutorials from lots of great people, supporting the community and helping people get up and running. So thank you very much. I hope I've been able to teach you a little bit about Houdini, and got a short time for some questions before we're going to get kicked out. Okay, so I taught you everything. Good. Okay, thank you very much.